All right, we're back. We're going to be on page 7. I went back and tried to check these. 9, 10, and 11 definitely checked out. 12, I got lost in the woods. I don't know. I'm pretty sure 12 is right. 12 is definitely right if this is right. And like, do I have any reason to think that's not right? I don't really know. The derivative of cosine is definitely negative sine. So I'm in a negative sine of x. I think it's right. I don't know, but I had a lot of trouble technologically. I should have checked them on Wolfram Alpha. That's another source that you should definitely use because it'll give you like alternate representations, which is so useful, especially for the trig stuff. But I did not do, I neglected to do that. So here we are. So let's see if we can do this. So the derivative tangent is secant squared. The derivative secant is secant tan. If I went with u equals secant, then I would need like, I'd still have one tan left over and I don't know what to do with that. So I'm gonna make this tan squared, secant squared, then dx. And then one of those secant squareds is gonna become tan squared plus 1. And then still we have a secant squared. Okay, so we're saving this. We're gonna do our u substitution. U is equal to tangent du is secant squared of x dx. Getting there. So it's gonna be u squared plus 1 du. Okay, so still going. U to the 4th plus u squared du. All right, here we go. We're going to integrate and go back to tangents. 1/5 tangent to the 5th plus 1/3 tangent to the 3rd plus c. There you go. I'm feeling good about that one, I think. Remember, you can always slow it down, speed it up, whatever. The derivative of tangent is secant squared, not enough. The derivative of secant is secant tan, not enough. The only thing I think I can do here is replace tan squared with secant squared minus 1. Oh, I see. Ugh. How much work are we doing on this? I'm going to do not a lot. I'm going to say that because I just worked them out, I know these antiderivatives, and so I'll just write down what I know. Man, what a bad problem to end on. All right. The antiderivative of secant cubed is the average of the derivative and antiderivative of secant, which is kind of weird, but it means that it's secant tan plus the natural log of the absolute value of secant plus tan, which like we literally did this problem in this set of notes. So if you're not sure where that comes from, go back and look. And then minus the natural log. Oh, well, this is kind of interesting because I guess I can like combine things. Absolute value of secant plus tan plus c. So if we wanted to, we could simplify this to secant tan minus, right? Because you're subtracting 1 from 1/2. Secant plus tan. All over 2, and then plus c. Weird problem to end these problems on. Should I end the video there? Yeah, maybe. I think. Because the next one, I think the next video will be short. Well, unless something bad happens, I think the next video will be short, but it's like so different that let's stop here and then come back and do that in the next video. So see you in the next video.